Thank you. Good morning, good afternoon, and good evening, everyone. It's an honor to be here today. So welcome to our talk on web isolation. So my name is Pedro Fortuna. I'm founder and CTO at JScrambler, and I've basically been working in security for as long as I can remember.
I guess I'm Jazz. I've been that was a wonderful readout of the bio. Had I known, I would have inserted more silly things in there. I've been working in security for as long as Pedro has known, I guess.
So we want to start this talk with a little story.
Pedro, it's 2 a.m. for some of us. Are you sure you're going to dive into this?
I think we need to risk it. So this story is about a chip that most of you may have heard about, the Titanic. That's right, you guessed it. It was built in Belfast in their famous shipyard, and I was actually lucky enough to visit during the OWASP AppSec EU of 2017. But we want to talk about how it was built. Many people don't know this, but when it was built, it was bleeding edge in many ways. So the bottom of the ship was split into 16 major watertight compartments, a technique to ensure the stability of the ship despite the presence of damage. And it could remain afloat with at least 2 adjacent watertight compartments completely flooded. That's like the worst situation they could imagine back then. So it was deemed to be unsinkable. But depending on the exact location of the hit, at best, it could withstand the flooding of up to 4 compartments without sinking. So you know how the story ended. It collided with an iceberg that resulted in the flooding of the forward 6 compartments. Even though it did not end well, compartmentalization was a great idea, and it's still used in ship design to this day. So the basic idea is that damage on a single section of the ship does not compromise the whole ship. So the problem with the Titanic was that its implementation was flawed, but we'll tell you more about that later.
That's a pretty naughty cliffhanger there, Pedro. Tell us a bit about the history of web isolation.
Sure. So the first real attempt at isolation inside the browser was introduced by the same origin policy in '95, where interactions between 2 different origins are restricted. But you can do this. You can embed a third-party code directly from a third-party server into your executing context. And actually, this code has the same level of privilege as any other same origin code. So where's the restriction? Actually, the same origin policy is quite complex. You can embed, which was the example I just shown you. What is restricted is some writing to and reading raw data from cross-origin domains. So the reality is that it is very complex with lots of exceptions. And to this day, most developers do not fully understand it, which is a frequent source of security issues. 2 years later, we were given the iframes, with which we can isolate 2 cross-origin documents of scripts running on the same web app. But soon enough, people just felt the need to poke a hole through it. So coming up with different ways to have communication between the 2 cross-origin documents. And only 13 years later, we threw the towel finally and made it official with the introduction of the web messaging API that gives us the post message possibility. But this didn't solve every problem that we had. Iframes actually had too much power. They could, for instance, navigate away the top window, among other things. So it took a while, but 13 years later, iframe sandboxing was here and introduced which would greatly restrict what an iframe document is allowed to do. So, but we also have a bunch of configuration attributes that you're seeing in the screen that gives us the options to relax some of the restrictions. So almost at the same time, we got CSP version 1, with which we could set a domain-based allow listing. Later, it was found broken, and you can read all about it in this paper. Plus, it's hard to maintain. So later versions fix that, but are not straightforward to set up. So the main limitation we see with CSP is that it does not cover all the behavioral angles. If you allow a script, it can pretty much do everything it wants. You cannot restrict further than just allow it or disallow it, with the exception of the network part. So the problem with this isolation and defense mechanisms is that people will fight them and will push for ways to relax them into what they need to make the application work. So things like JSON-P and cores are good examples. But if the isolation mechanisms were more granular and configurable, perhaps we wouldn't feel the need to open holes in these protection mechanisms. So here's the timeline of these features. You'll notice there's a huge gap between 97 and 2009, which makes you wonder what the browser people were doing during these days.
So this is a great historical perspective. What browsers provide us with is a whole lot of these fantastic basic primitives. All of the things that Pedro talked about seems to give us a lot of what we need to make our units of isolation smaller and stronger so that we can provide integrity to our web pages. That's what we are looking for. And yes, they have some problems that we talked about, but can we do something on top of these primitives and build something stronger? And I think that the answer is yes, and you shouldn't just believe me. The community has built all kinds of interesting mechanisms of isolation on top of what browsers provide. And so it's hard to figure out a good way of visualizing this, but this is how I think about it. Roughly speaking, you can divide up the approaches for doing isolation into either things that are doing transformation, where you change the source code, or virtualization, where you change the environment. So I plotted 3 of these projects here. There's Google Kaha, with which I was intimately involved, which uses a combination of virtualization and transformation to build the sandbox. There's JSReg, which tried to do the same thing, but used more lightweight transformations. And then there's JScrambler, which essentially relies more heavily on virtualization. But essentially, all of the approaches that you will find on doing web isolation fall somewhere on this spectrum. And the trade-offs that you're making is a trade-off between how much work you want to do and how strongly you want to protect the assets that you're protecting. So, to protect your ship, you can either virtualize, you can make the dangerous APIs that your application uses be less dangerous, so you can transform it and just remove the dangerous parts entirely. If we continue with the ship analogy, right? You basically want to keep the meaning of your application the same. So let's have a look at what transformation looks like. So this is transformation. Take a simple JavaScript application. It consists of functions like alert that come from somewhere else. You can think of this as the system call equivalent, but for web browsers, right? You have strings and arrays, the native types, and you have functions which you have written yourself. Now, I'm not going to dwell on this very long, but this is my most favorite transformation, like most favorite programming language transformation. It's the basis of almost all language transformation-based sandboxes that you can see. What it does here is, let's say you transform the functions that can be malicious, so that whenever they reference a system call or a native object, they don't get the powerful objects from your browser, or from your environment. Instead, they only get that which the caller controls. Now, I'm oversimplifying here. Those of you in the audience may already be saying, but Jazz, you haven't thought about eval, you haven't thought about walking the prototype chain, and you're absolutely right. But this is the basis for creating a pure language sandbox, and you should give you a little bit of a flavor. Now, this is not just limited to JavaScript. It also works for HTML, where did I freeze? It also works for HTML, and actually for HTML, it can even be a little bit easier because the power that is necessary, that is expressed by HTML or by CSS is less. Specifically, imagine if instead of some CSS rule that was changing every div on the page or every bold tag to be the color blue, if you simply prepended like gadget123 to it, now it only applies to a specific part of the third-party code. Using that kind of transformation, you can limit the amount of control that some third party has over your entire application. That's the transformation tool in our toolbox. The second one is virtualization. Now, I call it virtualization, but you all really already know this as polyfills, and you all know polyfills. They present a feature that is not present in a particular browser version. Virtualization is like polyfills, but we need them even when such features already exist in the application. But it's not redundant because we want to override the default behavior. For example, let's say if you have a date, and all browsers do, you can just provide them to the third-party application as virtualized authority. Maybe you don't care about timing attacks from this particular third party. You can also have XHRs. Now, XHRs, you might want to provide a virtualized version of XHR that always proxies content so that it always goes to your servers only or can't connect to arbitrary servers out in the wild. Now, you can tell that when I'm talking about ActiveX, I'm talking about a browser that's thankfully long since dead. But the point that I wanted to make here is that if your browser happens to not even provide a powerful object, now every browser now provides XHR, but there was a time when that was not true, you could use this same technique to use something more powerful like ActiveX to provide a version of XHR to your application. Now, similarly, you can provide like attenuated versions of location and document. What you are essentially doing here is providing virtualized versions of the original application. And the trick, the hard part, the strong part here for security is that you have to create polyfills in a way that can't be bypassed. And all of the projects that use virtualization that I've mentioned come up with different ways of achieving that. Now, I'm going to speed through this, but if you look at the things that I'm talking about here, there are three principles I want you to take away from how native browser isolation features are used and what properties you look for in these native browser isolation mechanisms. The first one is compartment size. The size of the unit of isolation varies between each one of the natively provided browser versions. You can have entire domains or origins. You can have whole pages. You can have just the iframes. You can have individual scripts. You can have individual functions. You can have individual actions, just a specific API call. Now, the smaller the compartment, the more resilient your web application is. The trade-off that you're making here, as you can imagine, is more decisions. The more decisions you need to make, the longer the setup time is, and the more difficult the configuration effort. The second thing that you need to keep in mind is the isolation material. The stronger a material is, of course, the more resilient your web app will be, but drilling holes into even strong materials weakens them. And you start to see hints back to the story that Pedro began with. iframe, CSP, mechanisms that we use to do web isolation are weakened, not because we have to poke holes in them to get what we want done. Those holes aren't there because web browser implementations are broken. They're there because the isolation mechanisms that are provided by the native browsers don't always align with the users, and developers come up with creative ways to poke holes in them. And the third one is a little bit subtle. It's visibility and user friendliness. Sometimes I joke, developers are people too. They need APIs that work well for the use cases that they are building and for their threat model. Now, some materials like the same origin policy and iframes work for threat models that have not kept up with how web developers develop today. They don't provide you with any visibility. You want, yeah, it's certainly not out of the box. I think that this brings us back to our cliffhanger, Pedro.
Yeah, and we are back. So like we said, the implementation was flawed and we promised to explain why. So in short, with the Titanic, there were 4 problems at least. So the compartments were still too big, only 16 compartments. So any compartment being compromised, it was like a huge portion of the ship. The materials were definitely not iceberg ready. It was stronger materials were needed. The damage model was incomplete or incorrect, which translating to our context, it means that the threat model was wrong, and lack of visibility. So for obvious reasons, no one spotted the iceberg in time. So visibility and analytics, which is an interpretation of what is happening, what you can be seeing, are definitely essential. So now we have time for some demos. So we are doing 4 small demos, and we have the same scenario throughout these demos. We are using a login page for a mock-up banking website. And this website uses a third-party chatbot service. So in some runs, we'll replace the regular chatbot script for a compromised version of that script, which will then attempt to leak the login credentials of the user. So you'll see a few options in the bottom that allows me to reload the website with different demo configuration. Okay, so let's do it. Let's start with the baseline. So here we'll show you an example of what happens when isolation is lacking. So this is the demo website. It contains mostly first-party code and the third-party script that I told you about. It's not really doing anything in particular. It's just a mock-up script. And now what we are going to do is replace this script with the malicious, and that is the icon of the chatbot service. And next, I'll be replacing this script by the malicious version of this script, like represents the compromised version of the scripts. This is the compromised version. So it is overriding the onSubmit event handler with the malicious version, which is collecting the username and password from the form and XHRing it to a malicious domain, in this case, malicious-api.jscramble.com. So let us log in and see what happens. We have a dashboard for the attacker, and I'll show you. This is the dashboard for the attacker, the drop server, and the password, username and password were correctly exfiltrated to this dashboard. Okay, so the problem here is obvious. It's lack of isolation. The third party could grab the credentials and exfiltrate them. So what we are going to do next is to load the iframe in to load the compromised scripts inside an iframe. So here we go. So basically, we now loaded the malicious lib. So you see an error. I'll explain in a bit. So the malicious script is loaded inside the iframe. So it doesn't have access to the form altogether. The iframe is loaded from a subdomain, so it's cross-origin, and you benefit from the same origin policy. So here we are, and here is the code. So it couldn't find the form and event handler to override. So hence the error that you are seeing. Okay. So even though we mitigated the problem, this can potentially require re-engineering of the app because we need to move these third-party scripts to iframes. And we need, and perhaps we even need the collaboration of the service provider. Re-engineering might be a bit complex and require a whole new protocol to post message things back and forth. And some services will not even work properly if they are isolated in an iframe. So an analytics service, for instance, expects direct access to the full DOM of the web app. So by moving that to an iframe, we are transforming asynchronous events to async, and that can create race conditions and all sorts of nasty problems that we need to solve. So it's no wonder that most websites just end up adding scripts directly to the main window, and that they expect that. Otherwise, they will claim that they just won't work. So third uses Caja. Hey, Jas, why don't you do this one?
Sounds great to me. So we're going to do the same thing. We turn on the compromise script. Now remember, and we run Caja here. The script that we're about to compromise isn't supposed to have access to the network. It's to do its job normally. And when we enable Caja, actually, I'm using a subsequent follow-up to Caja called secure ECMAScript here. It's derived from Caja. What we do is we create a component and we whitelist that component. Inside this component, we provide just the APIs that are needed. In this particular case, it's just create element and append child. And now when the script runs, it is able to continue, a proper script is able to continue to run the same way and log the user in. But because the compromise script did not get access to the ability to exfiltrate data, as you can see, no new passwords ended up on the drop server. The important thing to recognize here is that it provides a similar kind of capability that we got from the iframe version, but because Caja uses the transformation technique that I was showing you earlier, it can continue to provide synchronous access to these APIs. The downside is that you need to now have a whitelist of all of the APIs you're going to call ahead of time so that you can create this sandbox properly. How about web page integrity?
So to avoid these caveats, we developed a sandboxing solution that can seamlessly be integrated into any web app. So you're seeing the dashboard, which is right now completely wiped clean. And we need to add an agent to the page, and immediately we get visibility on what third parties are doing, and we can use rules to either allow or disallow such behaviors. So the dashboard is empty, and right now I'm reloading the page with the agent and to see what's going on. Okay, so I've done that, and immediately I get an alert, which tells me that the onSubmit event handler was overwritten. This is the form that was compromised, and this is the attacker's new onSubmit function, which I already explained before what it does. So right now it's not being blocked, but we will do that. This is the confirmation of the file that has done it. And essentially this is it. Let's move forward. see what else is going on. So I'll log in. And here's the exfiltration notification. Okay, so the malicious-api.jsgrammar.com was contacted, and we see that email password and domain information was passed using the same compromised file. Okay, so the next step, and here you are, you can have confirmation 2 sets of credentials were stolen already. So here are the rules. We're just mitigating the exfiltration of the credentials first. So any network request towards malicious-api.jsgrammar.com will be alerted and blocked. And I already have the rule. I just need to enable it and apply the configuration and wait a bit for the deployment. So now we will start blocking the exfiltration. Just takes a bit. And to save us some time, I'll probably just fast forward this a little bit. So what will happen is the on-submit poisoning is still there because we haven't done anything regarding that. But the exfiltration was blocked. So the next thing that we'll do is to actually get rid of the on-submit poisoning. So any behavioral change to a form in this page will be alerted and blocked. So we have the rule, enabling it, applying it, and here, again, in the login page, and we'll see a notification that gives us confirmation that the on-submit event handling was correctly blocked. Okay, so the demo may lead you to think that we need to find about things and only then block it. But the rules engine actually allows you to set allow lists beforehand. But you can name one script that needs access to the form fields, and then you can preventively say only these scripts can access the forms. So let's move quicker. Okay, so the talk is coming to an end, but we still need to address the challenges ahead. So to understand the challenges, it helps understanding what we have been doing wrong. So in terms of browser-based security features that provide isolation, things have moved slow and erratically. And the reason is because there was never one feature whose purpose was to provide full isolation for browser-based apps. So isolation was more about stitching together a bunch of different mechanisms like CSP or same origin policy and try to cover as much surface as possible. So this is both complex and error prone and inevitably leaves some holes or blind spots. So beyond the browser, there were very few initiatives that tried to come up with a holistic approach for client-side web isolation. One such solution was Google Caja, but sadly, eventually was discontinued. And more recently, we have JScrambler's web page integrity, which we have been working on. You are muted, Jas.
So obviously, if that's what happened in the last 20 years, what we need to do in the next 20 years is actually follow through on this and provide a single holistic client-side web solution that covers all of these angles. For this, we need a broad, coherent plan, and these three principles that we've been talking about, reducing the size of the compartment, making the unit stronger and more developer-friendly, aligned with how the web is used today, is the way to cover the next 20 years. As we were building this, Pedro and I joked, the way to make this ship unsinkable is to give it wings so that it can fly. Not sure how feasible that is, but where are we?
Yeah. Thank you.
We have parts of the solution, like the one we've been working on. Ambitious plans take time, and there's a lot of the pieces here that are coming together. In spite of the analogy, the plan is not to build an unsinkable ship, but to lift web application security a little bit out of the water. And so we call on the security community to join us, and hopefully we'll meet you all in the future, and we can give this ship wings.
So that's all we have for today. Thank you. We also like to pay our respects to the late Sir Clive Sinclair. He was an inventor and a genius, and personally, he is responsible for me pursuing a career in computer science. It was a huge loss for a generation that fell in love with computers because of his inventions. Thank you.